creating innovative photonics components for digital-coherent communication technology. That's our goal at NTT Electronics Corporation. In the near-infrared wavelength region, we offer distributed feedback DFB lasers, which enjoy strong customer support based on many years' experience in the telecommunications market. Laser gas sensing technology brings enormous benefits in terms of reducing carbon footprint and realizing a carbon-neutral society in accordance with the Paris Agreement. We at NTT Electronics provide DFB-LDs and PPLN DFG lasers for gas sensing applications. As a result of the remarkable industrial development of the modern era, the Earth's environment is being damaged by the minute. For example, global warming, which is caused by the greenhouse gases carbon dioxide and methane, is believed to be a factor in a wide range of environmental changes. Applying the semiconductor technologies it developed in optical communications, NTT Electronics has developed a technology that uses laser to detect the different wavelengths of methane and other gases. Tunable diode laser gas sensing (TD-LAS) technology works by measuring with high precision the amount of laser light absorbed by each gas. In comparison with other gas sensing technologies, TD-LAS delivers high sensor output at low concentration ranges, enabling high sensitivity. This property ensures excellent performance in an ultra-low concentration gas sensor. Leveraging this characteristic, TD-LAS technology can be combined with a wide variety of applications to create tools such as maps of greenhouse and other gases with high precision and covering a broad range of gases. NTT Electronics DFB lasers are available in two types of modules. The first is a spatial radiation type TechCan module, in which a thermal module, a thermistor, and a DFB laser chip are mounted on a TO5 package, and a fiber output type 14-pin butterfly module, which achieves stable single-mode oscillation by mounting an isolator inside the package. NTT Electronics DFB lasers adopt the same multiple quantum well MQW embedded structure as an optical communication laser, achieving stable mode hop-free oscillation characteristics. Standard specifications are 2 MHz line width and side mode suppression ratio of 35 decibels or greater. Here, we introduce our product lineup. We offer 2 product lines based on waveband. The NLK series covers the O, E, S, C, L, and UL bands, from 1260 nanometer to 1707 nanometer, and provide output power of 10 milliwatts and 20 milliwatts, while the KELD series covers wavelengths of 1735 nanometer to longer wavelengths up to 2340 nanometer and provide 2 to 5 milliwatts output power. Please visit our website for details. Using high distortion quantum well manufacturing technology held by NTT R&D, NTT Electronics has achieved the manufacture of a DFB laser in the 2.3 micrometer waveband based on an indium-based phosphide semiconductor material system, a feat that had previously proved elusive. We achieved single-mode emission with side mode suppression of 35 decibels or greater and fiber output of 5 milliwatts. This is a sample measurement test of a carbon monoxide CO monitoring system. The laser light output from the DFB laser is passed through a gas cell that encloses the CO and is received by a photodiode. Measurement was conducted using the WMS technique, in which modulation signals are superimposed to improve light sensitivity and detect F2F signals using a lock-in amplifier. This is the 2F signal generated when absorption measurement is conducted in the CO gas cell. No distortion is observed in the baseline, so the SN ratio is excellent, enabling high sensitivity monitoring of CO gas. NTT Electronics offers consultation on a wide range of topics, including selection of laser wavelengths according to the gas types you wish to observe, selection of spectroscopic techniques, and system design. NTT Electronics is contributing to the reduction of global warming gases through the deployment of high-sensitivity laser gas sensing technologies. Your value partner, your key device. One chip coupler for RGB, very good performance, mass producible, customizable coupling wavelengths. Your value partner, your key device. The photonics products of NTT Electronics Corporation support digital-coherent communications. NTT Electronics Corporation leverages a full spectrum of devices to propose solutions to customers. The development of terahertz technology is accelerating in next-generation wireless communication and imaging. At NTT Electronics, we are developing and commercializing UTC photomixers in this field. Let's take a tour of our product lineup for terahertz applications. Security sensing technologies ensure safety and security in modern life. New technologies are being developed in this field that are safer for the human body and make checking procedures smoother. One candidate is body scanning using terahertz technology. Terahertz scanners are safer than X-ray scanners and have higher spatial resolution than metal scanners. Here we introduce a terahertz body scanner that is under development. These gates are embedded with arrayed terahertz transmitters and receivers. This technology visualizes hazardous materials in real time, even in environments where a large number of people pass through continuously. These gates use terahertz technology, which is safe for the human body, to provide highly accurate security checks. Next, we introduce terahertz emitter and receiver products from NTT Electronics that are suitable for terahertz imaging. The UTC Photomixer emits a terahertz wave with a frequency equal to the wavelength difference between the two incident laser beams. This device can generate waves anywhere in the terahertz spectrum, from narrow line width terahertz to incoherent terahertz waves to meet customers' system requirements. UTC photomixers are available in coaxial connector output, waveguide output, and spatial beam output types, depending on the output frequency and output terminal. The 1 mm connector output type, which corresponds to the highest frequency of coaxial connector output modules, outputs terahertz signals from DC to 110 GHz. Rectangular waveguide coupled photomixers can generate terahertz waves in the range of 70 GHz to 340 GHz by using 5 types of photomixers developed for different waveguide sizes. We also offer an antenna-integrated photomixer for the generation of terahertz waves exceeding 350 GHz. This product is capable of generating terahertz waves beyond 3 terahertz. The terahertz waves emitted from the hyperhemispherical silicon lens can be converted into a high-quality collimated beam with a single lens. In terahertz receivers, we have developed a Schottky barrier diode type receiver, which we call an FMB diode that operates at room temperature. By introducing an unprecedented low barrier height structure of less than 100 millielectron volt, the FMB diode can use up to 100% of the incident terahertz signal, wasting none of it in reflection. This feature enables the FMB diode to achieve the ultimate in high sensitivity and low noise. NTT Electronics currently offers 2 types of FMB diode product. The first is a product that incorporates a low-noise op-amp as a preamplifier, achieving high sensitivity of 2 megavolt per watt and low noise of less than 5 picowatts per root hertz in NEP when receiving 300 gigahertz terahertz. The other is a product that incorporates TIA with a bandwidth of 11 gigahertz as a preamplifier. Taking advantage of its wide bandwidth, the product can be used as an ultra-sensitive receiver for coherent detection, making it a powerful tool in the fields of passive imaging and terahertz wireless. NTT Electronics terahertz wave-related products can be applied not only to body scanning and non-destructive testing, as you have seen, but also to post-5G wireless communication. Even in unexplored fields such as terahertz technology, NTT Electronics will continue to research and develop high-performance devices for realizing customers' dreams together. Your value partner, your key device,